what came into my mind when I first saw the question, I realized that if you want to calculate the length of PQ, first we need to determine the length of FG. Okay? Just give me a second. Okay. Okay, so we need to calculate the length of FG first. Can you stop talking? Stop talking. We need to calculate the length of FG first using the distance formula, which is what I did up to there. Okay, so the length of FG was square root of 18 units. Right. Now, to carry on after that, I saw, okay, that if I want to calculate the length of PQ, okay, I'm going to use the radius of the circle, so I can join F to P, okay. If I join F to P, I'll get a radius. Am I right? If you join F to P, you get a radius. If you join P to G, you also get a radius. Remember, the radius of any circle is the same throughout that circle, right? Then, since we have got a line from the center of the circle, which is PQ, which is the one that you want to calculate, it means I can use theorem 1 from circle geometry. Line from center perpendicular to a chord bisects the what? The chord. So it means if FG is square root of 18 units, means FQ or QG is going to be half of the square root of 18. So I'm going to use the theorem of Pythagoras. Okay, but it's not the only way, and I'm open to other ways. Okay, so if I use the theorem of Pythagoras in triangle FPQ, I can calculate PQ because I can determine FQ. I know that FP is the radius from circle geometry. Please be aware that questions like this that have got circles, you can use your knowledge of circle geometry. Okay, be aware of that. So if you see a question like this, remember that you did circle geometry from last year, and that can be applied. Also, in a memo, whether for the department or not, if there's more than one way of doing it, all those options will be provided. So you do it based on what comes into your mind first. All right? So, the next thing after this is for me to say FQ, okay, or rather I'll say, yeah, FQ is equal to half of F of FG. And I have to give a reason for this. That would be line from center, right, perpendicular to chord. Okay, so what this means is that FQ will be equal to half of this. Okay, I can just write it nicely as the square root of 80 all over 2. Okay, allow me to just recalibrate my board because my pen is not working properly. Don't know why. Let me recalibrate. Okay, are you following so far? Huh? So FQ is going to be the square root of 18 over 2. So, Spokers, can you put away your phone there? Right? You must show that you have got an interest in the lesson. So FQ is equal to the square root of 18 all over 2. Since I now know the length of FQ, my radius, which in this case is equal to FP. So I can write here and say FP is equal to the radius R. And that will be equal to, if you go back to the original question, are you sure what happened with my technology? Yes? Just what? Just no. Okay. Okay. If I use the board, there are some limitations. Okay. Let me try for the last time. Okay, I'm going to try for the last time. If it doesn't work, then we can then try the board. So FP is got the radius, and that will be equal to, now if you go back to the original equation of the circle, is this one here. So the radius will be square root of what? Of 5. Okay, so that will be equal to the square root of 5. Okay, that's the length of FP, the square root of 5 units. All right, are you following? So we then say in triangle, I'll just call it FPQ. Okay, in triangle FPQ, if I use the theorem of Pythagoras there, it will be FP squared, okay, is equal to PQ squared plus FQ squared. So this will be FP squared is equal to PQ squared plus FQ squared. That's Pythagoras. Okay, now my FP, it is the square root of 5. Okay, my FP is the radius, that's square root of 5. Then PQ is the one that I want to calculate. And then FQ, I got this as the square root of 18 all over. So I have to square it. Okay, then I'll solve for what? For PQ. So this will give me a 5. Then that will be PQ squared plus, that will give me 18 over 4. Alright? Then I need to solve this. Okay?
Attention please, and please put all the grade 12B, go down to the drawing room now to donate blood.
Okay, so this will give me 5 minus 18 over 4. It's equal to PQ squared. Right? Then from here we get 20 minus 18 over 4 is equal to PQ. So my PQ squared will be equal to, is going to be equal to 2 over 4. Then take square root on both sides. Okay? So you end up getting PQ equal to the square root of 2 over 2. Right?
So you went so far.
Which part?
You went so far.
Okay, which part? That's why I'm asking.
Went so fast.
You guys understand what he said?
Our radius is square root of 5. What is, listen. Please be aware that you did grade 11. Right? I'm going back to basics of sense. Okay, yes, we might, but I expect you to know that the square root of 5 squared is a 5. Right? Can you please? Alright, wait. What is that square root? The reason why I had square root is because if you go back to the original question, this is equal to r squared. Do you see that? 5 is equal to r squared. So, what is r equal to? Square root of 5. Right? So, I substitute that there. I got this. And this is the theorem of Pythagoras. Right? And then we have got PQ squared. You want to calculate PQ. And then we have got FQ squared. FQ is equal to square root of 18 over 2. This is a set. Okay, from last year we did set. If I square this, I'll get 18 over 4. Jan, you are the one who is asking. Look at what you are doing. Alright. So from here to there, you get 5. Is that clear to everybody? And then from here to there, is that clear to everyone? Yeah, you can use your calculator if you want. Then you take the 18 over 4 to the left. You simplify. You end up getting PQ squared is equal to 2 over 4. Okay? You end up getting PQ squared is equal to what? 2 over 4. Then you take square root on both sides. Okay? Now, this is not the only way, and this method might be slightly longer. If you did not see this way, then you might use the midpoint. Can I have your attention? Like what Okutus said yesterday. You can find the coordinates. Can you pay attention? You can find the coordinates of Q by using the midpoint formula, right? Then after finding the coordinates of Q, use the distance formula to find PQ. But if you are in an examination, whatever method comes into your head at that moment, you use that method. But the question can be done in what? 2 ways. Whichever method comes into your mind, use that method. Okay? Both methods will be acceptable. But I'm not going to prescribe to you and say, only my method is the only way of doing it. No. Okay? It's not the only way. All right? Any question? Yes? Any question? Are we clear now? Okay. You're part of the lesson. All right. Let's get on. Now let's move on to number 7. Now, yesterday I sent you a message and I asked you to do the question, right? Because I wanted you to apply what you know from last year, try and answer that question. Okay? And listen carefully. When you write your June examination, please be aware that you must expect questions like this. Okay? And some of the questions are higher order questions, like question 7, that's a level 4 question. You can come out of the paper and say the paper was hard because of a question like that. Right? So it's unfortunate that most of you did not bother to go over the question. Alright? Okay, so can I have your attention? Alright. The reason why, can you control yourselves, please? The reason why I asked you to do this question here, it's part of preparing you for what's coming. Okay? It's part of preparing you for what's coming. So, number 7 says, can you stop talking? Stop talking. If H is any point on major arc DE, now which one is our major arc? Our major arc is this whole length here. That's the major arc. Okay? So H is any point on major arc DE, and we are told that H is here. Right? We are supposed to calculate the size of DHE. DHE is this angle here. Okay? Now, depending on how you were taught inclination from last year, you might need to use your knowledge of angle of inclination. You might also need to use your knowledge of sine rule or cosine rule. Because all questions which involve angles in analytical geometry, they can be answered using angle of inclination, cosine rule, or sine rule. Sometimes you might need trig ratios. But if you look at it, this angle here is part of triangle DEH. And triangle DEH is not a right angle triangle. Therefore, we cannot use trig ratios to calculate that angle. Now, if you want to carry on here to calculate the angle, it would be better to calculate the coordinates of H. The question is, it's a high order question. So you might have to think about a way of calculating that angle. So in my case, I would want to know what is the length of DH, what is the length of EH. The length of DE is very easy to calculate because we know the value of Y at D, we know the value of Y at E. But we don't know the coordinates of H. So to calculate the distance DH and EH will be very challenging. So I hope you can agree with me here that since P is our center, if I construct a line from P to DH, that line will be perpendicular to DH, based on theorem 1 from circle geometry. Right? I'm open to anybody else who thinks they've got another way of doing it. Yes?
Please note any grade 10s that have not donated that. Please can you go down to the drama room now? Any grade 10s, please can you go down to the drama room and don't forget to take a pen.
Yes.
So we think about you calculate the point of H, and you use the Y value to make a line curve. Then you can use 10 to find possibly a right angle triangle out there. You use 10 to find out the value of EH, and then you can use 10 to find the value of GH, and then you subtract the two.
Okay, Ronald, did you do the question?
No, but
All right, some of the things that you said, they make sense. But I've got two ways of doing the question. I'm going to use the cosine rule, but to calculate the angle, I need to know what are the coordinates of what? Coordinates of H. Allow me to carry on, I'll give you an option. Yes?
Could you form radii with EP and EP and calculate
E and P.
yeah,
Yes?
because we have the coordinates of P and E and P, so we can find out the length of that.
Okay, we know the coordinates here.
And could we find out the angle of EPE?
EPE.
No, EPE.
DPE. So you're saying constructing that way, and then?
Can we find out the coordinates of that angle?
Oh,
And the side of the angle.
Okay, let's see what let's see what you're saying. I'm not gonna do it that way. No. Okay. So can I have your attention? Can I have your attention? So you're saying you join D to P, right?
And E to P as well.
And then E to P. Like that.
And once the angle at P be 2 times the angle at H.
Same rule. That's correct. So this angle here is 2 times that. Yes. Thank you for that. So it means that you have to join those two, you have to calculate this angle here. Right? But that angle you can only calculate using cosine rule. Okay? You have to use cosine rule. So that will be an excellent way of calculating the angle. Right? But I'm not going to do it that way. That's why, listen, that's why I asked you to do the question, so that you get an opportunity to sit down and think and try to see how you can solve the question. This is a level 4 question. Okay? It's a type of question we can pose you to come out of the paper and say, but that question was very hard. Okay? So, thank you so much for that. But I'm not going to do it that way. Okay? Yes.
So please
Listen. Okay. Okay, all right. Can you listen? Can I have your attention? Let's see. Listen. Let's see if we get the same answers. All right. Okay. Wait. Can you allow me to carry on with this? I gave you an opportunity to do the question. Okay. All right. So, in my case, what I'm gonna do, based on what came into my mind when I first saw the question, I'll construct a line from P to DH. Okay? Then I can maybe call this point here, I can call it maybe M. Okay? Hey, which one? Okay, let me just adjust it. No, I can't rewrite the whole thing. Okay, so what I'm saying, can you stop talking and pay attention? So what I'm saying is, I can construct a line from P to DH. Obviously, because point P is at the center. So if I construct a line, the midpoint of DH means this new line, which I can call PM, is going to be perpendicular to DH. You agree with me there? Right? So number 7, so we say construct, okay, join P to M. Okay, that's by construction. Okay, that's by construction. Right? Such that, okay, such that PM will be perpendicular to what? To DH. Okay, once we have that, then we can safely say, we can now say, therefore, if PM is going to be perpendicular to DH, okay, we can write here PM is perpendicular to DH. Our reason will be line from what? From center, perpendicular to chord. That's why those two are perpendicular. Then, from here now, I'm sure you can agree with me that yesterday we calculated the equation for we're given the equation for AC. You agree with me there? Yes. So what that means is, if DH is perpendicular to PM, it therefore means that DH is parallel to AC. Alright? So we can say, therefore, the gradient of AC will be equal to the gradient of DH. And this gradient, we got it yesterday, it was equal to what? It was equal to -1. Alright? Now, once I've got that, then I can I can determine an equation for DH. The good thing is, I know the coordinates here. Remember, at D, x is 0 and y is equal to what? To 4. We got that yesterday. Okay? So, the equation, it means the equation for DH will be y equals to minus x plus 4. Yes, because remember, if you want to know the equation of a straight line, you just need the what? The gradient, need the y-intercept. Okay, so I don't need to do any specific calculation there. I know my gradient is -1. I proved it from theorem 1 of circle geometry that DH is perpendicular to PM based on my construction there. Therefore, DH is parallel to AC. Okay? Are you following there? right? Then from here now, I now need to calculate the coordinates of what? Of h. To calculate the coordinates of h, I'm going to substitute the equation of dh into the equation of the circle. Okay? So, yesterday our equation of our circle is x minus 2 squared plus y minus 3 squared equal to 5. The new equation that I have for dh is y equal to minus x plus 4, right? So this one I can call it equation 1, and that one will be equation 2, right? Then, let me substitute now. If I substitute, so this will be x minus 2 squared plus minus x plus 4 minus 3 squared. So we are solving here simultaneously. And this is grade 11, by the way. Okay, term 1. So you get x squared minus 4x plus 4 plus, here you get positive 1. So you end up getting x squared minus 2x, okay, minus 2x plus 1 equal to 5. If I add those two, I'll get 2x squared. Then I'll get minus 6x. 4 plus 1 will give me a 5. If I take the 5 from the right, they cancel out, so I'll end up having 0. Alright? So what this means is I can factorize this, and then you get x equal to 0, which is the value of x at d. Can you pay attention? Leanne? So x equal to 0, or x will be equal to what? To 3. Now what this means is at h, x will be equal to what? To 3. Okay? X will be equal to 3. Let me try to move quickly now. So x is equal to 3 at h. I need to find the y value. The y value is going to be y equal to minus x plus 4. That will be minus 3 plus 4, and you get 1. So it means the coordinates of h will be x is equal to 3 and y is 1. Okay, so I found the coordinates of h. Now it becomes easy now. I just need to know to calculate the distance dh, calculate the distance eh. I know that the coordinates of d, the coordinates of e determine the length of de. Okay, are you following? Right? So from here, okay, I now know the coordinates here. X is 3, y is 1. Okay, so let's calculate the distance GH, EH, then determine DE, then use cosine rule to calculate that angle. Okay, it's a high order question. Like we can also use the, okay, I'll use the sine rule then. But the problem is the sine rule is not going to be possible because I don't know the size of this angle. I don't know the size of that angle. So the cosine rule is the best option. All right. Can you allow me to carry on? So I'm going to calculate the length of DH. Right? DH will be equal to the square root of 3 minus 0 squared plus, right, plus 1 minus 4. Okay, this will give me 9 plus 9, and that will give me square root of 18. Okay, that's the length of what? Of DH. Yes. What? What is 4 minus 3? What is minus x times positive 1? Negative x times 2, negative 2x. All right. So then we need to calculate the length of EH. So EH will be equal to, can you pay attention? So this will be 3 minus 0 squared, okay, plus y is equal to 1 minus, I think the value of y at e was at 2, isn't it? Yeah, we calculated yesterday. So that will be 2. So this will give us the square root of 9 plus 1, and then you get the square root of 10. Then the length of DE. Now, DE is very simple. It's 4 minus 2, and this will be a 2. Okay? Then now we can use the cosine rule. So in triangle DEH, if I use the cosine rule, okay, it will be DE squared is equal to DH squared plus EH squared plus, minus 2DH minus 2EH. Okay, cos what, and then we carry on. Right? So this will be DE squared will be equal to, it will be equal to DH squared plus EH squared minus 2 times DH times EH, the cosine of DHE. All right. Can I have your attention? I hope you are aware that if I want to calculate, can you stop talking? If I want to calculate the angle DHE, I can take this minus 2DH times EH cos DH to the right, then I'll take this DE squared. That's grade 11, right? Cosine rule. So I can write this as the cosine of DHE. Can you stop talking, please, and pay attention? Cos DHE will be equal to, if I take that, I'll get DH squared plus EH squared, right? Minus DE squared. This is all over 2DH times EH. Don't ask me where this came from. I just made cos DEH, sorry, cos DHE the subject. That's all. Like, it's not unusual. It's grade 11. Okay? Right. Chris, you okay? Are you sure? Okay. So that would be cos DHE will be equal to, now let's substitute now. DH, we got it as what? Square root of 18. So this will be square root of 18 squared plus EH, we got it here square root of 10. So that will be square root of 10 squared minus DE squared, which will be 2 squared, all over 2 times the square root of 18 times the square root of 10. Right? Now, I can simplify this. Right? And it's not grade 12, by the way. So I'll have 18 plus 10 minus 4 all over 2 times the square root of 180. Right? This is, I'm not using a calculator, but I can put this in the calculator once. So 28 minus that will give me 24 over 2 root of 180. And that will give me 12 over the square root of 180. So this is cosine of, I'm not using a calculator, that's why I'm doing it. If I was using a calculator and writing a test, some of the things that I'm writing, I was not going to write it. Now you can start smiling when you get here. Okay? If you smile, you get DHE is equal to shift cosine of 12 over square root of 180. Can you give me the answer to 2 decimal places?
26,57.
It is 26,57. Okay. All right. So this is how Mr. Chuponda would have done the question. All right. Now, if you consider the method that Sarasen said, it might be okay. It might be a little bit shorter, okay, but you can use that if you saw it. So we know. Can I have your attention? We know that our radius is square root of 5. Okay? So GP is going to be square root of 5, and then ED is going to be square root of 5. And then DE is equal to 2 units. So we can calculate that this angle here. If we just join the two. Okay, so if I join those two, so we can calculate that using the cosine rule. Right? So let's write that down. So maybe you can call that method 2. Okay? Can I have your attention? So we'll say GP is equal to EP. They are both equal to the radius, which is square root of 5 units. Okay? Then we know that DE is 4 minus 2, which is equal to 2 units. Okay? Then we'll say in triangle DEP, in triangle DEP, if you use the cosine rule, it will be DE squared will be equal to GP squared plus EP squared minus 2GP times EP times the cosine of GPE. All right, don't worry. If you are not following, be aware that it might bite you back later on. All right. If you have got your own private tutor, if you want to test if your tutor really knows, give them a question like this to do. Right? Okay. Without looking at the memo, because tutors look at memo, then they come and teach. GP equal to square root of 5 squared plus EP square root of 5 squared minus 2. Okay, GP is the square root of 5. And then the square root of 5. So that is the cos GPE. Okay? Now let's simplify this. You get 4, that will be a 5 plus 5, okay, minus 10. Okay, be aware that square root of 5 times square root of 5 will give you a 5. Right, so you get 10 cosine of GPE. Okay? Then, from here now, simplify this. Allow me to go to the next page. Okay, so you get, I'll take that minus 10 cos GP to the left. If I do that, I'll get 10 cosine of GPE will be equal to 10 minus 4, that's a 6. So that will be equal to 6. And then I'll get cos GPE is equal to 6 over 10. Then GPE will be equal to shift cosine of 6 over 10. Okay? What answer do you get there? What?
53,1.
So you get 53, please don't round it off yet. 53,13 dot dot. That's GPE. Okay? Then we say GHE is half of GPE. And we have to give a reason for this. Angle at center is equal to 2 times angle at circumference. Okay? And then you get a half times 53.13. And this will give you 26.57. Okay? So you could do that. Maybe, okay, probably it's possible, and I have your attention. It is also possible. In fact, I've got a second method, but because of time, I'm not going to go there. I've got a third method, but I'll just show you what the method. All right. Don't worry, I'll send you a PDF of this. Okay, today I've got internet in Everest, so I'll send you. All right, I'll show you a third method. All right, I'll show you a third method. The third method is almost like what Ronan was saying, but the way he said it. Okay. All right. Can I have your attention? Can I have your attention? You must be happy that we're talking about a third way of doing the same question. All right. Can I have your attention? Right. One way would be to construct a line parallel to the x-axis. Okay? You construct a line parallel to the x-axis such that it passes through point H. All right? Pay attention. Pay attention. Right? Then, now for this one here, you need to have found the coordinate of H now. Okay? The good thing is, I know that the gradient of AC is the same as the gradient of GH. I proved it based on my method. Can you pay attention? So we can determine, I hope you know this from last year, I hope you're taught that way. Right? If I construct a line parallel to the x-axis, it means that this new line here will behave like a new x-axis. Hence, I can use the angle of inclination. So if I know the gradient of GH, I can calculate the size of this whole angle here. Okay? That could be maybe the shortest way as compared to what we have done so far. But you have to know that it is possible to do it that way. Then you also find the gradient of EH. You calculate this angle. Alright? Are you following? And then you subtract the smaller one. Maybe you can call this one alpha. Right? And that one you can call it beta. And then this, the angle we want to calculate, you can call it maybe theta. So that theta would equal to beta minus alpha. And then you also get the same size. Now, all these options, listen, can I have your attention? Listen carefully. All these options are acceptable in the examination. Okay? As long as you show your constructions, if you are going to use a construction method, it is acceptable. Okay? So, if you are really interested, you can go home and try what I just showed you in terms of method 3. You can work it out. So that by the time you get to the June exam, the trial examination, the final examination, if you get a question on angles, you know what to do. Your heartbeat won't increase because you saw a question on angles. Okay. Well, I have tried my best here.